All right, good morning, AP Computer Science. We're taking a look at the answers to the Unit 2 practice assignment, those 4 hard math problems. We'll start with question 1, and I'm going to try and do all 4 of them in this video. So here's our first question. It's a bit confusing, so I'll just read it through. So in this question, we're taking a look at all the natural numbers up to, but not including 1,000, and we're going to try to find out what are all the multiples of 3 and 5, and then we're going to add them all up. That's sort of the objective of this question. So this is a great example of using a loop to process through a list of numbers, and here's what the answer is supposed to be. So let's see how we're going to get that. So I have that ready to go over here in the answer key. So here's how I did it. I'll try and zoom in so we can see. Whoa, there we go. Okay, so here's my main method, and I begin by creating a sum variable. So that's going to just keep track of what's the running total. And then the next thing is a for loop. I chose to use a for loop because in this case, I know where I'm beginning and where I'm ending. And if I guess I know how I'm increasing from one step of the problem to the next. So it seems like a kind of a slam dunk for the for loop as our use. I basically just ask a question each time. I check and see if it's a multiple of 3 or if it's a multiple of 5, the number that we're currently on. And then if it is, then I add it to the sum. And at the end, I'll print it out. So just to go over this in a little bit more detail, our int I here, this variable, is going to be changing every time through the loop. It's going to start at 0, and it's going to go up by 1 each time it goes through the loop. It's going to stop when I gets to, or basically when this is false, and that's going to be false when I gets to 1,000. So it won't include 1,000, which is good according to our problem description. So, so I is going to start at 0, and we're going to go and check to see if it's a multiple of 3 or if it's a multiple of 5. So what is this modulus operator? This is a really key thing to understand because it's used all the time in programming. So modulus basically finds the remainder in a division question. You can find a quotient or you can find a remainder, right? So, 7 divided by 3. So 3 goes into 7 2 times. So the quotient is 2, and that leaves remainder 1. So this finds remainders in a division question. So if we want to see if a particular number, I, is a multiple of 3 or 5, we can use modulus to divide by 3 and see the remainder. If it's a multiple of 3, then modulus 3 should give no remainder because it should be divisible by 3. Same with modulus 5. I can find out, I guess, if this is a multiple of 5. So you can see how this is useful. This is just one example of its usefulness. We'll see more as we go through the course. So that should solve that question for us. We'll go on to the next question, and we'll be taking a look at the Fibonacci sequence. So this is a pretty tricky question. Just to generate the sequence, I found I had a lot of questions, people asking about that, so that's great. I'll go over that. And then what is the whole purpose of the question? So considering the Fibonacci sequence whose values do not exceed 4 million, find the sum of all the even valued terms. So again, we're going to be using modulus to discover that. Here's a hint on how to do it, but we'll just go through the answer and see how I did it. So I'll back up to, I gotta zoom out. There we go. My questions disappeared, or my answers, I guess. Okay, so we'll zoom into that. Okay, so here is my solution. So again, we're just doing this in the main method. And I have 2 variables that'll keep track of my Fibonacci sequence. And whoops, I should have made in my question, I probably should have started with 0 and 1 or 1 and 1 at least, because if you started with 1 and 2, it actually ends up missing the 2. So if you're short by 2 in your answer, that's probably why. So I'm starting at 0 and 1. And A and B just represent sort of the last 2 numbers in the Fibonacci sequence. Sum is going to be the how much we've added up so far. So when we find a Fibonacci number that's a multiple of 2, then we'll add it to sum, just like the last question. So then I have ourselves a loop, and So what I'm doing here is with this for loop, I'm going from I is 0 to 4 million. And this is how I'm adding it up. So I'm saying I is equal to A plus B. So if I want to generate a new I basically just add A and B together. So it starts at 0, which is a little bit misleading. It's not necessary to be 0. I could have started at A plus B. That's fine. And then I just check to see if it's odd, or even, I guess, is actually what I'm checking. And if it is even, then I will add it to the sum. And then I switch the values of A and B. So for my for loop, I start at 0. And 0 kind of sucks because it's not really gonna, it's not gonna be a result. if we add it or not, doesn't really matter because it doesn't add up to much. So let's just go through. So 0 modulus 2 is 0. Sure, we add 0 to sum. And then check what happens. We set A equal to B and B equal to I. So we sort of move things forward. So A becomes B, so not that exciting. A becomes 1, and B becomes 0, B becomes, or I guess becomes 0. And then we flip it over, so now I becomes A plus B, which is 1. So now I is 1, which is less than 4 million. Is 1 multiple? No. So we keep on going. So now A becomes B, and B becomes I. So we kind of shift the numbers forward along the Fibonacci sequence, which is kind of replacing them. A lot of students did this with a while loop, and that's totally good. I actually, in some ways, kind of prefer the while loop solution. It's a little bit easier, I think, to read, but I wanted to show you sort of a for loop solution as well, so you could see how you might do this as a for loop. Might make an interesting question to try to convert from one type of loop to the other in the exam. So that's how I did that question, and again, just printing out the answer. For the third question, we're taking a look at the sum of squares and the square of the sums. And we're actually taking a look at the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. So in one of them, in the sum of the squares, we're squaring each number and adding it up. And here's what that looks like for up to 10. And in the second one, we're adding up all the numbers and then squaring it at the end. And so we get that as a result. So I guess the square of the sums is going to be a larger number. And then we're going to subtract them. So we'll subtract the square of the sum, we'll subtract the sum of the squares from the square of the sums. So basically just got to calculate those two things and then do the difference of them. And that can be a tricky thing to do, especially since squaring things in Java is kind of ugly. So let's take a look and see the answer, or at least one possible answer. If you answer things differently in your questions, as long as you got the right answer, it's the main thing. One nice thing about these answers is they're quite condensed. They're quite efficient. So it's nice to possibly see another way of doing things. Okay. So let's take a look and see. For this question, we have the sum and the sum of squares being calculated in the same loop. If you did two separate loops, that's totally fine. You're most welcome to have done it, one loop for one set and one loop for another set, and then did the difference. As it turns out, you could do them in one loop because the loop is really just going from 1 to 100 and then doing something possibly different with each calculation, but we still just really need to count from 1 to 100 once. So in this for loop, that's exactly what I'm doing. So I start at 1 because we're not interested in 0, and we go all the way up to and including 100 because 100 is part of the question according to the definition of the question. And of course, we're going up by 1 each time. So I'm using the assignment operator here, the plus equals operator. So the sum of the squares, I'm just going to be adding the square of whatever the current whatever the current count is. So first it'll be 1 times 1, and then it'll be 2 times 2, and then 3 times 3, and so on. For the sum, the square of the sums, I'm just going to do the summing right now, and then afterwards I'll do the math to do the squaring. So it's just keeping track of 1 and then 2 and then 3 and then 4 and just adding those numbers as we go. And that's what this plus equals operator is all about. It's sort of like this, the equivalent of saying sum equals sum plus I, or this is the same thing as sum of sum squares equals sum squares plus I times I. So it just sort of does it a little bit shorter. And then at the end, I print out the calculation. I don't actually store it in a variable. I just print out the calculation. So this is where I square the sum of the numbers from 1 to 100, and then I subtract the sum of squares. And so that's all kind of done in a nice tight package to prevent unnecessary additional code. And I don't know why I made it a long. That's just an int. I wonder if that was required. If it was required, if it went beyond, then whoops, I guess that's a problem that I should have mentioned before. So if you found that you were like stuck on the int, then I guess you could change that to a long. And longs are just extra big ints. They store the same information, but they have more space in them. I hope that wasn't an issue for you. If it is, then my bad. I apologize. The last question is probably the trickiest, and there's a number of ways to go about it. But basically, the idea is that we're looking for Pythagorean triplets, and apparently, according to this question, there exists only one Pythagorean triplet where if you add the sides of the squares, you get the number 1000. So in order to convey that information, we're asking you to multiply those three sides together because there's also only one answer for that. And then you can just answer as a single number, and that makes it efficient to print that out, and also doesn't give away the answer of what A, B, and C are. So we are going to take a look at how I calculated, I guess, the Pythagorean triples, and I think this hint is pretty useful. The constraints is not such a big deal. I mean, if you went over at that, all the way to 1000, that would be fine. It's nice to try to think about that if you have the time. So we'll go back to that question. So here's my answer. So I have a nested for loop. I guess I did go to 1000, so I guess I didn't need to. Whoops, that's okay. So we start at 1 because there's no such triangle with side length 0. And then we're going all the way up to, but including 1000, and this probably could change. We could have probably improved that constraint. And this is kind of keeping track of the values of A. The inner loop is keeping track of the values of B. So basically with this structure of a nested loop, I'll start with A equals 1, and then this loop will go through all the values of B while A is still 1. So, B will be 2 and 3 and 4 and 5 and 6, and A will still be 1. Eventually, it'll have gone all the way to 1000 and restart, and then A will go to 2, and then B will go through all the values possible for B, with A being 2. So it's sort of a brute force approach where you'll get, go through all the values of, or all the combinations of A and B. And then here, we're taking, doing the calculation where we take the Pythagorean calculation to see, math dot square root of A times A and B times B. So we're just solving for C given those numbers. And then if we add them together, we should get 1000 for that one particular one. And so I just check to see if A plus B plus C equals 1000. If it does, then I'll print out the value, and I guess I demonstrate the answer here as well. This will actually trigger twice because A and B, you could swap their values. So A and B, I forget what the values are, but if you have, say it was 3, 4, 5, A could be 3 and B could be 4, or vice versa. B could be 3 and A could be 4. So this will sort of trigger twice, but it'll be the same numbers basically. One thing to note is that I'm using a double here, and the reason is because we're doing a square root, and I'm not going to cast it to an int. I know that the answer should be an int. We should get one that is an int. So that is fair. I should probably think about that. But if you do cast it to an int, then you'll end up getting some false positive answers. So you'll sort of force certain answers to be the correct answer by chopping off those decimal places, even though they don't actually result in an integer answer. So I'm not casting it. There's actually another way to do this problem where you use this fact to generate C, and then you use the Pythagorean theorem to test I'm sort of using the Pythagorean to generate C, and then I'm using that fact to test. So you could do it the other way around, and I think that actually works out to be a cleaner solution. But this works too. So there you go. Those are the solutions to those four problems. I hope they were a challenge for you, and an interesting challenge at that. And I hope you feel like you have conquered those challenges and have gotten some more experience in programming as a result. So thanks so much, everybody. We will see you, I guess, on Tuesday or whenever you're seeing this video. We'll see you soon. Bye.